Hey everyone, get ready for an awesome adventure. Because today, we're diving into something you use every single second, your amazing eyes. We're gonna find out exactly how they work. You ready? Let's go!
So think about this for a sec. You're looking at, I don't know, a butterfly, or your best friend, or even me on this screen right now. How in the world does that picture get from out there and zap itself right inside your head? It's a pretty wild question, right? Well, trust me, the answer is even cooler. You got it. It all starts with a journey. And to really get how we see things, we're going to follow a tiny little traveler, a single ray of light on its super-duper fast trip. We're going to follow it from something out in the world all the way to your brain. It's going to be an amazing story, so stick with me.
All right, first things first, let's meet the stars of the show. I want you to think of your eyes like a pair of tiny, super advanced cameras. So cool, right? But here's the thing. They don't work by themselves. Nope, they have a partner, your brain. And let me tell you, they are the ultimate team.
Okay, so let's get this journey started. I want you to picture it. You're outside and you see a beautiful butterfly. The sunlight hits its colorful wings and boing! A little ray of that light bounces off and heads straight for your eye. Are you ready to follow that light ray? Let's do it.
So, our little light ray has a few super important stops to make on its trip through your eye. Think of it like a little obstacle course. It's got to get through the cornea first, then zip past the pupil and iris, get focused by the lens, and then bam, land on the retina at the very back. Let's check out what happens at each one of these stops. Okay, stop number 1, the cornea. This is that clear, see-through dome right on the very front of your eye. It's like the eye's front window. Its biggest job is to just let that light from our butterfly pass right on through. And it also starts to bend that light, or, focus it, just a tiny bit. It's the first step in getting a clear picture.
All right, next up, our light ray meets the iris and the pupil. Now, the iris is the cool, colored part of your eye. You know, what makes them brown, blue, or green. And it acts like a little curtain for the pupil, which is that black dot right in the middle. Here's how it works. If it's super bright out, the iris closes that curtain to make the pupil teeny tiny so not too much light gets in. But if you're in a dark room, the iris opens that curtain wide up to let in as much light as it possibly can. Pretty smart, huh?
Okay, so after zipping through the pupil, our light ray hits the lens. You could think of the lens as a super smart, squishy magnifying glass. Its job is to do all the final focusing. It actually changes its shape to bend the light just right so that the picture of that butterfly becomes perfectly sharp and clear right on the very back of your eye. It's just like the autofocus on a camera.
All right, let's recap. Our little ray of light has made it through the cornea, squeezed past the pupil, and been focused by the lens. It's about to land at its final destination inside the eye. But get ready for this. There's a huge surprise coming up.
And here it is. This is the crazy part. Because of how the lens bends the light, the picture that it creates at the back of your eye is completely upside down and backwards. I know, right? It's totally wild. So right now, as you're picturing that butterfly, there's a tiny upside-down version of it inside your eye.
So where does this wacky, upside-down picture actually land? It lands on the retina. The retina is like a movie screen at the very, very back of your eyeball. Its job is to catch that focused light, but it does something even more incredible. It's covered in millions of tiny cells that turn that light into a secret code of electrical signals that only the brain can understand. So this is probably the biggest question you have right now, yeah? If the picture inside our eye is totally flipped, why isn't our whole world upside down? Like, why aren't you staring at your ceiling instead of me? Well, this is where the eye's super partner, the brain, comes in to save the day. But hold on, before the brain gets that secret code, we have to meet the tiny little heroes on the retina that actually create the code in the first place. Let's give it up for the cones and the rods. So, these two types of cells have totally different jobs. First, you've got the cones. C for cones, C for color. They see all the colors, reds, greens, and blues, and they work best when there's lots of bright light. Then you have the rods. They see in black and white, but they are superstars in dim light. That's why you can still kind of see shapes when you walk into a dark room. Oh, and they're also awesome at spotting movement out of the corner of your eye. All right, so the cones and rods have done their job. They've turned the light into that top secret electrical code. Now it's time to send it off to headquarters for the brain's magic show. This is where the code gets turned into actual sight. So how does that secret code travel from the eye all the way to the brain? It travels along the optic nerve. You can think of it like a super fast data cable connecting your eye camera to your brain computer. It just zaps those electrical signals straight to the brain in less than a blink of an eye. It's incredibly fast.
And folks, this is where the real magic happens. Your brain gets this jumbled, upside-down code and it just knows exactly what to do. Instantly, it flips the image right side up. Whew, that's a relief. Then it takes the slightly different picture from your left eye and your right eye and smooshes them together to give you awesome 3D vision. And get this is my favorite part. It even fills in a tiny blind spot that every single eye has. You don't even notice it's there because your brain just paints it in. How amazing is that? Okay, so our eyes are clearly amazing. But you know what? The animal kingdom has some eye superpowers that are just out of this world. Let's take a quick look at a few.
But first, one last cool fact about us humans. Did you know you blink about 10,000 times a day? Seriously, every single one of those blinks is like a little windshield wiper keeping your cornea clean and moist. Okay, now let's see how we stack up against the animals.
Okay, check this out. We all feel like we can see okay-ish in the dark, right? Well, a tiger can see about 6 times better than we can at night. Can you believe that? And it's all because their retinas are packed with way, way more of those night vision rod cells we were just talking about.
And it doesn't stop there. Get ready for some rapid-fire facts. Chameleons, they can move each eye all by itself, so they can look in 2 different directions at the same time. How cool is that? And your dog? They see the world, but mostly in shades of yellow and blue. And then there's the mantis shrimp. This little guy is the champion. It has so many types of cone cells, it can see colors we can't even imagine exist. Mind-blowing. So, if there's one big thing to remember from all of this, it's this. Seeing is a team sport. It's never just your eyes doing the work. It's always your eyes and your brain working together perfectly that creates the amazing, colorful 3D world that you see all around you. You know, learning how your amazing eyes work is really just the beginning. The world is just packed with incredible things to see, from the tiniest little bug on a leaf to the farthest star in the sky. So go out there and use those incredible eye cameras of yours every single day. Keep looking, keep noticing things, and most of all, never, ever stop being curious.
And that really just leaves us with one last question for you. With those amazing eyes and that incredible brain working together, you literally have the perfect tools to be a scientist or an explorer. So, what new, what wonderful, what surprising thing are you going to go out and discover with them?